All right, I wanted to do like 2 year homework problems here, just so that we've got them covered for this projectile motion. We'll do 2 types of the problems because this section does give students, especially if you're new to physics, it kind of gives you issues. I mean, I'll just be honest. It's kind of I don't know if it's designed to be kind of a gatekeeper type thing, but it sure acts like it sometimes, and I don't like for it to be, but sometimes that's just the way the cookie crumbles. Okay, so let's take a look. But anyway, just remember this: everything. You get your time. Oh, let's not use that pin. That pin's terrible. Time, x-axis, or y-axis. All right. Everything when you're doing projectile motion here on Earth. Now we started class on Tuesday. We looked at the time you're going to find the y-axis. The acceleration is equal to g, which is equal to negative 9.8 meters per second squared in the y direction. Okay, acceleration in the x direction is equal to 0. Keep that in mind at all times, and then just take it from there. All right, so I'm going to look at problem 15 here. Problem 15, a skateboarder shoots off a ramp with a velocity of 6.7 seconds, okay, directed at an angle of 60 degrees above the horizontal. The end of the ramp is 1.4 meters above the ground. All right, and let the x-axis be parallel to the ground and the y-axis be vertically upward, and take as the origin the point on the ground directly below the ramp. Okay. All right. So, how high above the ground is the highest point that the skateboarder reaches? When the skateboarder is 1.4 meters above the ground. Okay. When the skateboarder reaches the highest point, how far is this point horizontally from the end of the ramp? All right. No problem. There it is. Problem 15. This is tricky. It's tricky because here's what they want. They're teaching you a lot of physics. So here's the ramp. Here's our skateboarder. And he's going to go flying off put a little baseball hat on him. All right, so he's going to be flying off this ramp at 6.7 meters per second. So they want 2 sig figs in our answer, 6.7 at an angle 60 degrees. Now that is not a 60-degree angle, but I like my skateboarder drawing. Okay, so our coordinate axis system looks like this. Let's get our angle a little better. There's 60 degrees. There's our velocity angle. Our initial velocity is 6.7 meters per second at 60 degrees. Okay? And the coordinate axis system is actually set up here. This is 1.4 meters. And then here's the end of the ramp. Okay? All right. So, we're going to add the 1.4 meters later, okay, because they want us to know the height we went, and then how far he went this way, or what his, when he gets to the maximum height. They made the problem a little bit easier, and they want the range when he's at the maximum height. Okay? So now we got the problem set up. In the next one, we're going to solve. In the next video, we're going to solve this.